I'm Anil Kumar, and in this video we'll explore angles which are even greater than 90 degrees for sine and cosine ratios. Question here is, consider the point P, K24, 25 units away from the origin on the terminal arm of angle A in standard position. Determine possible values of sine A and cosine A. So let's try to understand what is given to us. So let us say a point is given to us, P, whose coordinates are K24. We don't know what K is, but we know that it is 25 units away from origin. So from the origin, we know Y value is 24, so Y value is somewhere 24. So we'll just make one triangle here. Let that be the terminal arm with point P given to us as K24. We are also given that's 25 units away from origin, so it is 25 units away, so this distance is 25, so we are given that also. Now we need to determine possible values of sine A and cosine A. So the angle A is here, that's what we are considering, right? So that is the point P, that is the origin, and when we say that the terminal arm of angle A in standard position, it means that the initial arm is along the x-axis, correct? That is the initial arm, and the terminal arm is given to us, which goes through point P, right? So that becomes the angle A. Now let us find the possible values of K. What we can do is we can just draw up a perpendicular, and here we know that Y value is 24 and the R value is 25. So from here, this is the K value. So the K is so many units away, correct? So we can say, using Pythagorean theorem, that K square equals to 25 square minus 24 square, correct? So let's use calculator to find what is K square equals to. So it is 25 square minus 24 square, and that is equals to 49. Now if K square is 49, what is K equals to? K is equals to square root of 49, correct? So that is 7. Now square root of 49 is 7. So we get one value of K. So we get a possible value is 724. Now it is important to understand that whenever you do square root, you should actually write plus and minus. So we actually get plus and minus two values. Plus value of 7 and minus value of 7. That is to say that this triangle could have been formed even in quadrant 2, right? So kind of like this. Do you see that? Where the K value for us will be minus 7. So in this case, we found this to be 7 minus 7. And that coordinate point is the Y value of 24, right? So there could be a point. Let's call this point as, we'll call it P itself, but P dash, since the x value is different. So this coordinate point will be minus 7 and 24. So there is a possibility of getting two different answers for K in such cases. So you should be exploring both the answers when you are given such a question. That is most important to understand. So we'll work out sine A and cos A in both the quadrants, quadrant 1 as well as in quadrant 2, right? Here also, if you find Y value is 24 and R is 24 square plus 7 square square root, right? So you can find OP dash. OP dash is indeed equal to square root of minus 7 square plus 24 square square root. So if you calculate, you will get this as 25, right? So that is also a possible solution. So I want to highlight this point that whenever you have such a question, look for possibilities of more solutions, right? Now let's begin to solve. So in this case, angle A will be considered to be this angle. That will be our angle A. So that is the case 2, right? So we have two cases. So let me draw a line here. So we'll calculate for both the cases, correct? So we'll say sine of A and sine of A dash, okay, which is in quadrant 2. In this case, we'll say cos of A and cos of A dash, which will be in quadrant. This is quadrant 2, quadrant 1, 2 and 1, correct? These are the coordinates. Let me write Q here to make it absolutely clear. Coordinates, okay. Let's find out what are these values. As far as sine is concerned, sine of A is equals to opposite over the hypotenuse. And if I consider this, opposite is 24, so I get 24 over 25. So that is my sine of A. And in this particular case, it is again 24 is positive, 25 is always positive. The radius is always considered positive, right? So here also we get sine of A as A dash as 24 over 25, right? Since the opposite is this. But let's find the cosine values for each. So if you find the cosine value in the first quadrant, it is positive 7. So cos of A is equals to adjacent over hypotenuse, correct? Adjacent is plus 7 over 25. So you get positive 7 over 25. In quadrant 2, again if you figure out adjacent over hypotenuse, adjacent is minus 7. So in this case it is minus 7 over 25. So for cos A, we get two different answers, plus and minus 7 over 25. You get the idea, right? So we can say that in this case cos A is equals to plus or minus 7 over 25. However, sine of A is equals to 24 over 25, right? So that is how it is. In quadrant 2, we know sine is positive but cosine is negative. And that is the reason why we have two different solutions for cosine of A in this particular given condition. I hope that helps you to understand how sine and cosine should be calculated for angles which are greater than 90 degrees. You have to see one of them could be negative also. Okay, thank you.